Hi again. Capacity is a central concept in operations management. In this lecture, you will get a short introduction to capacity management. We all have an understanding of the word capacity. We often think of capacity as a set figure. For example, that this Swiss juice box contains 25 centiliters of juice, or that a bus can transport, say, 50 passengers. However, for capacity management, this understanding is not sufficient. We need to add an understanding of time to the equation. So the juice box capacity is 25 milliliters per filling. For the bus, it's 50 passengers per trip. As you will understand, this makes capacity an order of magnitude more challenging to manage. Capacity is of course not restricted to manufacturing. For example, ETH has a capacity of say 20,000 students per semester. What is the capacity of your favorite pizzeria?
To provide a definition, capacity determines the rate at which the operation can transform inputs into outputs and the quantity of a product or service that can be delivered within a given time period. Note that we should not talk about capacity without also talking about demand. Demand represents how much the market requires in a given time period. Capacity is how much an operation can make in a given time period. Ideally, capacity and demand should be balanced. The challenge is to match capacity to demand without wasting resources. Capacity can be calculated. On a high level, capacity equals total time available over time needed for task. To give you an example from truck manufacture, if a factory works one shift of 8 hours and the line takt time is 10 minutes per truck, we get 480 minutes per day over 10 minutes per truck in the final station. This equals 48 trucks per day. So the capacity of the factory can be said to be 48 trucks per day, or 240 trucks per week in a 5-day, one-shift job design. There are 3 different types of capacity. Design capacity is the expected output of an operation when there are no stoppages. Effective capacity is the expected output of an operation considering planned stoppages for maintenance, shift change, special events, and so on. Actual capacity is the expected output of an operation considering both planned stoppages and unplanned stoppages. We can now use these definitions to calculate, for example, efficiency. Efficiency is the actual output shown as a percentage of the effective capacity of the operation. We can also calculate utilization. Utilization is the actual output shown as a percentage of the design capacity of the operation. This shows the percentage of time the facility is in actual use, and therefore it demonstrates how well the resources are working. The central questions for capacity management are: how much capacity do we need and how can we get it? The first question requires an analysis of market demand and is a topic of later lectures. For now, we note that there are many ways to adjust capacity, spanning from radical to incremental. For example, we can introduce new machines, lines, or even factories. We can add a shift, increase working hours, or use overtime. We can source capacity from suppliers or even competitors. We can employ more people. We can increase the throughput speed in our processes, reduce quality errors, or reduce other wastes in processes and products. Altering capacity can be difficult, time-consuming, and costly. There is, however, one important thing to notice. Any change in capacity may have no effect if it does not address the capacity constraint. Capacity constraints are also called bottlenecks, which we will dedicate a lecture to later.
So now you know a few things about capacity and you can feel good about that.